the messages that we can send using the SQS and SNS and kinesis. Okay, so these are the few services that we have seen in the previous session, but in the today's session we'll start with the serverless overviews. Okay, serverless overviews means we are going to see that how without managing the servers we can execute the tasks. Okay, so serverless doesn't mean that we'll not have the servers. Serverless means that we are not going to manage it. Okay, so because the task that we'll be having, so it obviously it needs to have, it require the servers, but serverless means that we are not going to manage it. Okay, so let me share the screen so that we can have the introductory overview of the serverless, then we'll execute it. Give me a second, let me share the screen. Okay, I think screen is visible. Yes. So we'll start with the serverless. So, but in the serverless, the first point that you can see is it's a new paradigm in which the developers do not have to manage the servers anymore. That means the developers or even the people that are using the AWS, they need not to manage the servers. But it is nowhere written that server does not exist, because we need to have the servers. Serverless means that this might sound confusing कि serverless का मतलब शायद servers नहीं होंगे. So it's not like that. Serverless means that explicitly we are not going to manage the servers. We just deploy the code and servers will be managed at the backend. Okay, say that they deploy the functions and the virtual functions are going to be deployed. So initially the serverless means इसका मतलब equal to means the serverless we used to refer it as the functions as a service. So we are going to just deploy the virtual functions that are going to perform all the tasks on my behalf, and they are going to be executed. Okay, okay. So the next point that you can see, serverless was pioneered by the AWS Lambda. So this is the very important function, and we are going to see what is AWS Lambda in our today's class. But now also it includes anything that is managed, that databases, messaging, storage. So all these things are going to be managed by the AWS Lambda, for which we are not going to manage any of the servers. Okay, serverless does not mean there is no this already discussed. It means you are just don't manage them, you don't provision them, or basically you're not going to see this server. So automatically how things are going to be managed. Now this serverless basically is going to function in lot of things. So this is suppose users. So S3 bucket, if they want to access some of the static content which is present in the S3 bucket, they can use it. Or if they want to log in using their credentials, if they are having the user ID and password, and if required to be validated, for that we are going to use the service Cognito. Okay, now let's suppose if they want to have they want to call few of the APIs that are not present right now within the AWS. Suppose Python की या JavaScript की कुछ APIs हैं that you want to call, so that can be called by the with the help of this API gateways. Now let's suppose you want to access any of the content which is present in the S3 bucket. This is going to be the static content. For this, first of all, you need to log in using Cognito. Then you're going to make a request using the API gateway. Now this request will land in the AWS Lambda. So this is the function Lambda. Your queries is going to land on the AWS Lambda, and ultimately the Lambda function is going to send the request to the DynamoDB. So this is of course a database, but the user is not going to manage this DynamoDB, because all the managerial work is going to be done by this Lambda functions. Now it is written serverless in the AWS, where all we can use this serverless. AWS Lambda uses serverless, DynamoDB, Cognito, API gateways. So this can use the serverless. This can use the serverless. Basically the requirement or the objects that are being required. Amazon S3, they, let's suppose you upload. Now let's take an example. But I have uploaded the image of the coffee, and I have uploaded the image of the car or the beach. You might have seen I have not stored it, I have not managed the servers, neither the databases, how it is going to be stored, uska primary kya hoga, secondary kya hoga. So we have not basically looked upon that part. So that means AWS S3 bucket. So whatever content you are going to store inside this S3 bucket, they are also the part of the serverless. Okay, so SNS and SQS. So whatever messages you have sent using SNS or the queries that you sent to the SQS that we have seen in the last class, but it is also going to be stored into the database, but we are not going to manage servers for that also. So AWS Kinesis Data Firehouse is also Aurora serverless, step function, Fargate. So these are the Fargate is used for the deploying of the containers that we have also already seen using the Docker class. So that means all these all these services that are mentioned here, these are using the serverless, or they are using the lambda functions for assessing the data that is being present in the DynamoDB. So these supports the serverless features. Now, what is AWS Lambda? So before we reach on to the DynamoDB, this is a database. Of course, this is used for the storing and fetching of the data. But what is this Lambda function? How this is going to deal with the DynamoDB, and how it is going to deal with the S3 bucket? Better you can draw one or two more arrows. S3 bucket can also be directly linked with the Lambda function. Okay, this Cognito can also be directly linked with the Lambda function. So this Lambda function can be associated with lot of other services. Now, if you'll see here, why AWS Lambda, how this is going to be different from the EC2 instance. Now, better in EC2 instance, there are few of the things that I need to manage at my own, like virtual servers in the cloud. What is EC2? These are going to be the virtual servers, EC2 instances that I can create. Uske upar beta user script we you to launch as a bootstrap. So what is this? These are the virtual servers in the cloud, but these are going to have limited by RAM and by CPU. You might have seen multiple times I've shown you that we can have vCPU is equal to 2, vCPU is equal to 4, or RAM can be given. So I can decide on RAM and the CPU usage as per my business needs. So it is limited by RAM and users. I can decide the RAM and CPU usage for my EC2 instance. Similarly, this can be continuously running. Let's suppose I create an EC2 instance and it is running. बेटा ये तब तक चलता रहेगा until and unless I terminate the instance. Yes or no? कि EC2 instance when I create it, this will keep on running until and unless I shut down or I terminate the EC2 instance. So that's another point in EC2. And scaling means intervention to add or remove servers. No doubt, beta, in this case as well, you can simply add the auto scaling groups in order to scale up or scale down the EC2 instances. Okay, so we have already seen auto scaling groups. EC2 के अंदर भी आप scale up and scale down कर सकते हैं as per the business requirement, but for that obviously you need to make few changes. आप उसमें you need to use the auto scaling groups. After 70% of the capacity, new instance should be launched, or when the CPU utilization is more 50%, or the number of requests increases from 100 to 200. So there are few matrices that you need to decide first, then only it can work on the this auto scaling group. But that means in Amazon EC2, even it is a virtual server, but there are a lot of things that are required to be managed by the user. But when it comes to the AWS lambda functions, how this is different from the EC2, but it is going to invoke virtual functions, so no servers to manage. Virtual functions कैसे invoke होंगे? How it is going to invoke the virtual functions? Suppose it needs to call the REST API, so it needs to call the REST API. It will send a request to the lambda function. Now lambda function will invoke the virtual function that is going to land upon DynamoDB. It will execute the query and it will return the result to the lambda function. So lambda function can invoke the virtual functions in order to have the task done. So virtual functions are invoked to, because there is no servers to manage. Moreover, limited by time, short execution. So that means it is going to be very limited by time. It is not going to be present forever, like it is going to be constantly running. Okay, this is going to be limited by time. That means for whatever duration you are going to use this lambda function, it will be up and running only for that particular duration. Once you are not going to use it, it will not be running. What is the benefit of this? Beta, you will be charged for only that much duration जितनी देर आप यहाँ पे queries pass करेंगे, और for that particular duration for which you are invoking some of the requests in AWS Lambda. Otherwise, if you're not sending any request, so this will not be up and running. So which is a very big advantage as compared to the Amazon EC2, where the instances will be constantly running even if you are doing anything or not doing anything. So it will be constantly running. So that's a very big advantage. Another point is this is run on demand. Of course, we have discussed whenever we need to have it. So if we need to scale up or scale down, this is going to be automated. So it is written as scaling is automated, but a no auto scaling group is required. So automatically when it sees the requests are increasing, so automatically it is going to scale up and scale down. So these are the few of the advantages of AWS Lambda upon AC2. Okay, I hope you are getting these points. But are you getting these points? Am I audible? Hello. Okay. So coming on to the next one, let's see the benefits of AWS Lambda. And by the way, we have already seen, we have made a comparison between traditional EC2 instances that we have seen up to now and the Lambda function that we'll be looking for in our today's session. Now let's see the benefits of the AWS Lambda, how it is beneficial as compared to the EC2 instances. So, but these are few of the technical details and a few of the points that may be important for the examination point of view. So it is going to have the easy pricing. Okay, pricing is very easy, pay per request and compute time. Whenever you're going to invoke AWS Lambda function and pay per request, jitni बार बेटा आप request भेजेंगे, you will be charged for only that much time. So in free tier, you can have 1 million AWS Lambda requests that are eligible. For 1 million AWS Lambda requests are eligible for free tier. And once you cross that limit, then for every 400,000 GBs of compute, okay, so this is free tier eligible is given. So 10 million AWS Lambda requests and 400K compute time is free, is eligible for the free tier. Okay, and moreover it is integrated with the whole AWS suite of the services. And what is the suite of the services? But these are the few of the services which is directly linked to the Lambda function. I'll show you a lot more services that are directly linked with the Lambda function. So it is already integrated with the lot of AWS suite services, and it is integrated with many programming language as well. Like you want to run the Python code, you want to run the Java code, or if you want to run the or any other code that you want to run, C sharp code if you want to run. And likewise it is enabled and it has provided the console. Compiler is already provided where you can execute your codes, and it is already integrated with the AWS Lambda. Okay, we'll see that in a practical. So in easy monitoring through the AWS CloudWatch, I'll show you today the CloudWatch, the logs. CloudWatch में क्या होता है बेटा? CloudWatch is going to generate the logs. Log files are being generated. So using these log files, using this AWS CloudWatch, we can very easily monitor that at what point which all queries are executed, which are successful queries, which have failed queries. So we can monitor very easily using the CloudWatch. That we'll see also in today's class. Now easy to get more resources per function. Okay, up to 10 GB of RAM. So one of the Lambda function can have more number of resources that are associated with it. Up to 10 GB of RAM it can consume, and increasing RAM will also improve the CPU of the network. And by default, it is not it is provided up to certain extent. But uh, if you want to increase that RAM, suppose you increase that RAM, it will eventually help you in the improving the CPU performances and the network bandwidth as well. So these are the few of the benefits of using the Lambda function. Coming on to the next one, AWS Lambda language support. So this is, I have already told you, supports Python, supports Java, C Sharp, Golang, Ruby, PowerShell, and custom run. This is also important. Suppose these are the few languages that are present which the AWS Lambda function support. But let's suppose you want to run any other language, so you have the provision of the custom runtime API, so you can run any of the language provided if it is present as a custom runtime API is present, then you can use it. So community supported example, Rust is going to provide you, is one of the language, and provides you with a runtime API. You can, using that runtime API, you can execute it. Okay, so these are all the languages that are supported. And moreover, you can have the Lambda container images as well that you can run, because for that you need to have ECS or Fargate is preferred for running the arbitrary Docker images. Okay, so Docker images may everything is going to be bundled onto the single image that you can run on the ECS or Fargate using the Lambda container. So these are the few points. Now coming on to the last slide, what's integrated a whole AWS suite of services. So see this, but these are the integration AWS Lambda integration main one. So this get integrated with the API gateways. Okay, so gateways means that some requests are coming and you want to filter out and you want to send it to the different service. Kinesis, that means you are going to temporarily store the data, then you want to process it and store it into the database. DynamoDB is of course the database that will be generating. If today we'll have the time, we'll try to create a table. Okay, अब database में हम table भी create करने की कोशिश करेंगे. Then S3 bucket we have already seen to store the data. CloudFront, okay, so CloudFront services also we'll see this CloudWatch events that are going to keep an eye on every of the services, and if needs to be triggered something, so CloudWatch is going to be responsible. CloudWatch logs, SNS and SQL services we have seen in the previous session, and Cognito for authenticating the user IDs and passwords. Okay, so these are the few services that are directly, all these services are directly linked with the AWS Lambda. Okay, now coming on to the example of the serverless thumbnail creation. Thumbnail creation means suppose user uploads something and you want to create it as a thumbnail. So what is going to happen is, suppose this is an image that user want to upload in this bucket. So user upload this in a bucket, so it is going to trigger one of the function. एक virtual function trigger होगा towards the lambda function, and this lambda function creates a thumbnail. So this you can write the code beta in any of the languages, Java, Python, Node.js, or anyone. So once it is going to trigger the event, this lambda function will do it, and it is going to push that particular thumbnail image back to either to the same bucket. तो वो सेम बकेट के अंदर भी बेटा it can push it, or it can push the thumbnail image to the any other bucket. Along with that, this can parallelly execute lot other things. So one thing is parallel multiple execution is it is pushing the thumbnail image to one of the bucket. This can be new bucket and this can be the original bucket. It can send it anywhere. At the same time, it is pushing few of the important metadata details in the DynamoDB. Metadata means the details about the data. So it is pushing in the database as well, like what is the image name, this thumbnail image iska name kya, like beach.jpg, what is the image size, let's suppose it is 50 bytes, creation date, etc. So all these details can simultaneously be pushed in the metadata in the DynamoDB, or they can push it into the new bucket as a thumbnail. So all this work is going to be done with the help of AWS Lambda, which can create a thumbnail. So this is one of the example, serverless thumbnail creation, where the Lambda function plays a very important role for the creation of the thumbnail. Okay, coming to the next very important one, example serverless cron job. Now what is this cron job is, suppose we have the CloudWatch events event bridge. So some of the events are going to happen and CloudWatch is going to trigger it. Okay, now you can set it every 5 minutes or every 10 minutes or every 1 hour an event is going to be triggered, and lambda function after that particular time, lambda function can perform the certain tasks. Suppose after every 1 hour you want to take a backup and you want to store it into the any other place, okay, secondary storage, or if after every 1 hour you want to count the number of requests or the number of processing, number of user logged in, or any other thing. So the serverless cron job is basically going to trigger the events at a regular interval of time, so that the after every few minutes or every few hours the lambda function can perform the same task that is required. Okay, now pricing, AWS Lambda pricing example, how the pricing is going to be, by the way. So if you want to have the latest pricing, because this keeps on changing from time to time, so whatever pricings today we have might change after 4 months or 6 months or 1 year of time. So you can visit this particular link in order to get the latest prices of the AWS Lambda, how the prices are going to be charged. But as of now, pay per calls that we have seen just now, for the first 10 million requests are free, and then 0.20 per 1 million requests. Therefore, 0.20 cents are required to be paid, or $0.20 is required to be paid for every 1 million requests. That's very cheap. You can see 0.20 cents for 1 million requests. That therefore per request you can see $0.000002 per request is required to pay it. So this is extremely affordable. Okay, then the second option is pay per duration. Either you can pay the pay per calls for whatever duration you're going to invoke it, or you can do the pay per duration in increment of 1 milliseconds. So for milliseconds it is also payment model. If you run it for 5 milliseconds you will be charged accordingly. If you run for the 10 milliseconds you'll be charged accordingly. So pay per duration also and pay per the calls also, two models are there. 400,000 GB seconds of compute time is free per month, that is required. Okay, 400,000 GB seconds compute time per month is free of cost. And after that the seconds is 1 GB, it can perform on 1 GB of RAM. And you can see 3,200,000 seconds of function on 128 MB of RAM. And after that you will charge for $1 for every 600,000 GB seconds. So this is just a pricing, no need to cram anything. This is for just for the simple sake of understanding that once the free tier is over, how the chargings are going to be happening on the Lambda model. Okay, it is usually very cheap to run AWS Lambda, so it is very popular. This is done. Okay, try to read it once. बेटा एक बार पढ़ो इसको. Okay, so but I hope you have read this. So let's move on to our management console and let's try to execute AWS Lambda function. Let's see few of the important services it is going to provide, and let's explore AWS Lambda. Okay, so let's go to the management console and let's log in. So okay, so let's try to write here. I'm going to search for Lambda. I've got the Lambda function. Okay, so this is how it looks like. Uh, so, but this is from this you can create a Lambda function, but I'm going to change it slightly so that I can show the basic one. So in the URL beta, instead of functions, I'm going to change. Let's suppose if I change instead of function. Let's write begin. All right, begin. So the moment I change to the begin, so this screen is going to pop up because I want to explain to a lot of things in this page. So this is going to start from here. So obviously you can see that the create function, create a function, and because it is going to have some of the education value, I want to show you. So it is written AWS and let's let you run code without thinking about the service, and this makes truly the serverless service. So the idea is that we can use the any type of programming language we want. For example, the .NET Core. So you can see the .NET Core, Go, Java, Node.js, Python, Ruby. So every language is these are the few of the languages that are going to be supported. And if you want to have around 10 provided by uh, any of the language, so you for that you need to have the APIs. Let's suppose, so if it is written the custom runtime, so it is written, you can see the AWS Lambda runtime 1. Okay, so you can go to the Python or the Node.js. Let's go to the Node.js, and so from this code you will have it written. So it is written as exports.handler event console.log return hello world from the Lambda. Okay, so upload it into the lender console. If I'm going to do it, so this will run the code for you. Okay, this is going to run it. And even in the Python you will see the simple code, lambda handler print event, and what is this event? Hello from the lambda. So let's try to print this. Okay, so if I'll simply go and run, click on the run, so you will see you here it is printed hello from the lambda. So you can understand the power of this lambda function. So multiple languages are supported and console is provided to you. You can use it, or even the custom runtime environment if you are working on any other interface, if it is not this one, so even then it can work. So hello from the lambda for Python code, it is displayed. So that would we have provided right here. It's very simple, right? Now let's suppose, let's go to the next one. Let's click on the lambda respond to the events. When I'll click on this, better try to understand, this is very important service. Now suppose this is a video streaming and it is sending a data to the lambda. It is processing it, and you will see hello from the lambda, hello from the lambda, hello from the lambda, again and again it is printing. So if you'll click on this now, if I'll keep on clicking on this, now you will observe lot of requests are parallelly coming, and the lambda function will automatically scale to solve this. And automatically, now since the requests are coming slow, so it has stopped scaling out and it will stop scaling. Okay, so automatically scale in and scale out operations are going to perform, and it can, the traffic can originate from anywhere. Suppose it is from working from the mobile, so messages are going to be sent. So first of all, messages are going to be sent from mobile or IoT backends. Then from mobile or IoT backend, it's sent to the lambda function, and from lambda function it is going to be executed. Now let's suppose if you're the image files, so data processing, there's a bucket here. From this you can send it to the lambda function. It is going to process it and display the result. So you can understand the power of the lambda function, that whatever the data you are going to have it, it is going to process. So concurrently, beta, this streaming service, analytical service, images, buckets. So parallelly, a lot of data can flow. So that's the another point. So here you will see the lambda response to the events. Once you create a lambda function, you can configure them respond to events from the variety of sources. So this is source 1, 2, 3, and 4. Try sending a mobile notification, streaming the data lambda function, or place a photo in the S3 bucket. So for all those services, you can execute this one. Okay. So that is why you will see here it is called as a serverless. No servers you will see here that is going to be deployed, but still things are running and it is going to be executed and shown here. Okay. Now if we'll see the next scale seamlessly, click on this. Now we'll see the invocations, how many times you have invoked. 82 times, 135,000. Cost is zero, because up to 100 millions you are going to cost is zero. But as I'm going to increase this, let's suppose I'm going to increase this one, so you'll see automatically increased, and the cost is going to be increased here accordingly. Okay, so the moment you increase it, let's click this again and again, you will observe this is going to increase the so this is going to increase the cost. So cost matrix is also available here that you can see. The based on the number of invocations, you can see the cost. Done. So basics things are done, and let's move on to the now let's move and create click on the create functions, create a lambda function. So we have been provided with 4 options here. Okay, so we can choose from any of the 4 options for creating the lambda function. Author from the scratch, use a blueprint, container image, and browse serverless app repository. So as of now, we'll be using a blueprint. So build a Lambda application from the sample code and the configuration tests for the common use cases. So I'm going to use the blueprint for creation. Okay. Now, if you'll click on the blueprint beta, you'll find out lot of options that are already existing. Okay. So let's try to write here, hello. Okay. So I'm going to use this one, hello world. Okay. So you can use this hello world Python, just for the sake of understanding. And you will observe the moment I click on name hello world Python, I have got already the blueprint of this lambda function created, that is a starer AWS lambda function, which is working on Python 3.7 hello world Python. Okay. Now click on this one, and now you can click on the configure. Now the moment you click on configure, let's try to write the name of this. Let's write the demo lambda. And after that you will see the execution role, and here it is written create a new role with the basic lambda permission, use an existing role, or create a new role from AWS policy template. So there are multiple options from which you can choose the role. So I'm going to keep it as it is. Now coming here, you will see the Python 3.7 runtime architecture used, and JSON document print landing function and value one. So basic program is given event and the context. Print value one plus event key one, value two print key two, value three print key three. So or the fourth one is return event key one corresponding to the echo back to the first key value. So the basic Python code is being written here, and it is going to be executed. Okay. And this code is very important because it is going to be handed over to lambda function, and we are going to put three values into this. Okay. Let's scroll and click on create function. This is creating. This might take certain time. Creating function demo lambda. Okay, so successfully created. So here is the created, and you will find a lot of important points: code, test, monitor, configure, different name alias, and the versions is given, and then the actions are also given. So let's try to understand one by one. So the very first thing you will see is the demo lambda, and the lambda function .py is given. So this is the code that we have got. Okay, now let's try to see this course stored, and if I'll click on this lambda py, and I have got this lambda function done, and we can see that the function could we add multiple same statements are given here that we have seen before. And why not we go ahead and test this code. Now if I'll click on the test, I can test this code. Okay, I'll click on the test, and here it will call me creation of new event. Let's save it as it is. Template is, let's keep it as it is. Events key one, key two, value three, key three, value three, which will print the hello world. Okay, we need to give the name here. Let's write demo event, and shareable share event sharing this, let's keep it as a private, and let's try to execute and create this. Demo was created successfully. Okay. Now if we'll create on the test, you will see, but at the moment I create on test, you will find the event name is demo event. I have written responses as value one, value one, value one, value two, and value three corresponding to key. I've got the answer, and the end request report is given, and you can see here, but the duration is This is executed for 1.35 milliseconds. Build duration is for 2 milliseconds. Memory size is 128. Max memory use is 36 MB. And init duration, init means initialization. Okay, init means initialization, because this is the very first time we have executed. So beta init duration, initialized duration is also mentioned as the 91.99 milliseconds. So otherwise, now once we have, I'm sorry, now once we have launched this, once we have lambda function, let's create this and test once again. Okay, now the next time is, you will observe beta, this is the second time I have executed. You will find here memory size, and when I'll scroll this, you will not find the init 91.99. Initialization duration is not mentioned because we have already initialized it. Okay? So this is how you can execute. Or let's try to do few of the things. If I'm going to remove this comment, and if I'm going to write a comment on this one, okay, so that means raise an exception. So that means return event key one will not be returned. Instead of this, the exception something went wrong should be returned. So let's try to test this. Okay, and response is, let's, okay, changes not deployed. So changes are not deployed yet. So I need to first of all deploy. So updating the function demo lambda. So this is deployed. Now if I test now, so you will see it is giving me the response is error message, something went wrong. That we have seen the error type, exception is there. Okay, file is gave a raise exception. So this is how the things are going to work. And this time duration 5.9 milliseconds, build duration 6 milliseconds, size 128. Max use this one because we have deployed it. So we have got the initialization. Init duration is also mentioned, that is 116. Second. Done. So let's make it like it was originally. Okay, now this is done. We have seen the console, and let's move on and see the another important points. And now we'll see the other things, that is going to be monitor. Okay, and so if I go to the general configuration in this, if I'll go to the monitor, and you will see here the the configuration description started with this one. Time is for 3 seconds, memory is given, and ephemeral storage is also given. And of course you can edit all these things. Now let's suppose you want to increase or decrease the memory size. Memory is 128 MB is given, and this can all the memories you can change it. Time out is 0 is given, and which can, let's see, up to how much time this can go. Also the maximum time is up to 15 minutes timeout you can have, but I'm going to reduce it to 0.3 seconds. So that's a timeout given. Execution mode is also given, and you can use the existing mode or create a new role from AWS policy template. So you can play around and see this. Now coming on to the another point, let's try to open the monitor, and in this monitor you'll find a lot of important details, like you will see the CloudWatch metrics. I have told you we'll see the CloudWatch metrics. Now whatever AWS Lambda is going to perform, but how many successful test cases are there, how many failed are there, kitne duration के लिए थी, everything is going to tell. Invocations कितनी बार बेटा invoke किया, we have invoked it 2 times. Okay, हमने 2 बार invoke किया, so 2 times we have invoked. Duration in milliseconds is given. Error count, कितनी बार error आया बेटा, so error count is given. So 1 time we have got the error count. So this is very important. Cloud metrics is going to give you very important details. Throttles, asynchronous delivery failures, and the concurrent execution. So all these things are going to be very important one in order to monitor. And these details you might not get using the EC2 instances. So that is how the Lambda functions perform a lot better. Okay. So If you'll see matrix is given, these are all matrix, and if you'll click on the logs, so see, but you have three log files are generated. First for the 1.38 millisecond, second one for 1.17 millisecond, then 5.9 build duration, and memory size is given, memory in use is given. So this is the log files that are going to be generated here. Okay, so latest invokes that I have done, and if I'll click on any one of this, let's click on this one. So this is going to take me to the another interface. Now you'll see better the moment I clicked on any of this particular CloudWatch logs, it is going to take me to the another one. So you'll see here the report request value, loading Stara request ID, and at what time all these things are going to happen. So all these things are mentioned here. Okay, request ID, error whenever we got the exception, something went wrong. So this is traceable, most recent call, last one. So the time duration, timestamp is mentioned. Okay. Now if I'll go to the log AWS Lambda, now if I'll go to the AWS Lambda demo Lambda, now this is the CloudWatch. Okay, so we have been working on this interface with this demo Lambda. This is a different interface, but when I'll go to the CloudWatch, this is the interface for the CloudWatch, and we have got the logs. But when I clicked on AWS Lambda demo Lambda, but you will observe within the CloudWatch, I already have two logs generated. Okay, so this is linked with each other. So I have told you in the slide that which all services are directly linked. So Lambda is already linked with the CloudWatch. Okay, so we have seen the CloudWatch events or CloudWatch logs. These are directly linked with the Lambda, and you can see here a lot of other details, that retention peer KMS ID, creation time, and all these important and metric filters. So these are beyond the scope. So the only purpose of showing you this is that it is automatically going to be linked. Now let's come to the our original one demo, and let's move to the code. And it can work. Once again, let's try to use this and see what is going to happen in our. So this is the error. Okay, so this is going to generate an error, and something went wrong. This is working. Now let's try to move to our the CloudWatch log. This one, and you will see the latest one, but on the top you will see the latest one, response ID. So this is the latest one. Go to this one, and you will see the third log file is automatically generated. You can refresh this. So recently the third log file, because we have got log streams, and the third log file is automatically generated, and it has showing you all uh, the execution logs that we can have. Error is there, so you'll find the most recent call and something went wrong. This is working. Let's move back and make the things like it was earlier. So execution result, raise an exception at this and deploy. Perfect. So this is working fine. So let's see a few more settings, and if you'll move down to this code part, you will see that code, how much the size of code is 443 bytes, and modified at this time. Runtime settings, on what Python version it is running. So this entire code is running on what Python version, it is already mentioned 3.7. Lambda function, lambda handler is what? Lambda function inside this lambda function we'll have the lambda handler. You will see lambda function dot lambda handler. If you have ever invoked beta any of the function, you might know this. Using dot operator we can call the one. So here you will see that lambda function dot py. Inside this dot py will have the lambda underscore function. So that is why the handle is lambda function dot lambda handler. Lambda function is present inside this lambda handler. Architecture is given. Okay, so these are the few of the basic things that we have here is. So let's move to the next one, configure. And under this permission section you will see role name and demo lambda, and you can use the resource summary is it is attached with the CloudWatch logs. It is already attached with the CloudWatch logs. Okay, and if I click on demo lambda role like this, and it will end up using the IAM management. So this is the lambda role. IAM roles can also be associated with this. The moment you click on this link, you will end up on this particular screen. Now this is the IAM page. So this is the IAM, identity and access management. Under this permissions, now if you want to see which permissions are associated with this one, so you can click on AWS lambda, and here you will see which is associated with this one. So let me try click here. So you can attach if any other point you want to attach. Now under this beta, if you'll see this AWS Lambda execution role, which policies, which permissions are attached to this particular IAM one. So when you click on this, you will see the CloudWatch logs are associated with this IAM policy. So this IAM policy and this IAM policy is attached to this this demo lambda. Okay, so click on demo lambda, you will end up on IAM management console. Here you'll see the permissions and the policies, and the only one permission policy is present as of now, which is automatically created with the IAM, and it has AWS lambda basic execution role. Click on this execution role and you will find that it has been assigned with the permission of the CloudWatch logs. Okay, so it has CloudWatch logs already with us, and it has the limited write, uh, which our assess level is CloudWatch can write the logs. Now coming on to the next one, coming on to the our lambda interface. So it is associated with the CloudWatch logs, and the resource name you can see here. So allow logs create log group, allow logs create log streams. So all these permissions are provided here. Okay. So we have discussed the interface, this one. Okay, so this is for the lambda group. So I don't think there is any more details required to understand in this one. So I beta, do you have any doubt related to the AWS lambda? We have seen the basics of AWS lambda. Are you able to understand this? Beta, is it clear? Please reply yes, no. Are you listening to me? Are you able to get this?
Yes, sir.
Okay. So, but in that case, take a 5 minutes break and then we'll start with the another very important topic. Okay. So we'll start with the another very important topic after this. So come after 5 minutes. Okay, so better let's get started, and we'll discuss couple of more important points related to the AWS Lambda, and then we'll start with the uh, another important topic, the serverless solution. So if everything needs to be collaborated, and if you want to deploy any of the single, let's suppose a website or any blog or anything, how all these things are going to come together and how these are going to be interacting with each other, and it can perform the useful tasks. Okay, so let me share the screen once again. So let's have a discussion. Okay. This is done. Okay, so we'll try to understand that lambda is going to impose few limits as well, and what are the limits per region. So memory allocation, 128 MB to 10 GB, 1 MB increments, it can be there. Maximum execution time is 900 seconds, so it cannot have the execution time more than 15 minutes. Environmental variable size can be fixed to up to 4 kilobyte, not more than that. Disk capacity in the full container dot slash temp can be 512. Concurrency execution can be maximum 1000. In the deployment model, lambda function deploys a site compared to the zip file 50 MB. So all these are the nothing to explain into this. Few of the limitations related to the lambda functions are mentioned here. You can read about it. Coming on to the lambda at edge. No, lambda at edge means you have deployed the seeding using the, okay, just give me a second. Lambda at edge required के नहीं. Hmm, रहने दो बेटा, lambda at edge. ठीक है. Leave this lambda at edge, and now we'll be starting with the serverless solution, and I'll explain you how the serverless solution is going to work. Uh, yes. Now, mobile application, my to-do list is the next point that we're going to start. Now we'll see how these multiple points are going to work with each other. Okay. Now we want to create a, now let's suppose the next point we are going to start is serverless architecture, that how multiple things like this, how these things are going to interact with each other. This is what we are going to see in our today's this point. See, this is how the things are going to work, and we are going to look at all this important architecture, how different services are going to interact with each other in order to work as a one. Okay, if you want to deploy any of the website, how the things are going to work. Now we want to create a mobile application with the following requirements. Let's suppose you want to create a mobile application, expose a REST API with the HTTPS. Few APIs that you need to have, you will be using with the HTTPS secured servers. Of course, this is going to have the serverless architecture because we'll be using the Lambda function. Users should be able to directly interact with their own folder in the S3 buckets. That means multiple users should be able to directly interact with their own folder in S3 bucket. So that means within the bucket there will be lot of folders, and each user should be able to access only one specific folder, not the entire bucket. So how we can restrict the access, how we can provide the access, how other things are going to work, this we'll see. Another thing that you want to have is it user should authenticate through the managed serverless service. So authentication should also be there, that if I'm having the username and password, there needs to be some of the serverless service that is going to authenticate whether the username is right or wrong. Then user can write or read to-do lists, but they mostly read them. They can either write it in the bucket or they can read the data, but most of the cases they can read it. The database should be scalable. They should have the some high rate throughput. Okay, so suppose I have a static website, so most of the users are going to come at my place and my blog. They are not going to write anything into it, but they are going to read it. So that's the scenario. Okay, so let's try to see how the things are going to work. So but let's suppose mobile app REST API layer, how this is going to work. Suppose you have the mobile client. Okay, So using the very first thing is, if they are going to send the REST APIs, and which is the first service that is going to come in hand is the Amazon API gateway. Okay, Amazon API gateway, it will send the APIs. Now we need to authenticate. Before, first of all, we need to authenticate whether the user is correct or not using the user ID and password. So we are going to authenticate using the Amazon Cognito. This is a serverless service that is going to authenticate the user based upon their IDs and passwords. So once they are going to be verified, they are going to lead them to the Amazon API gateway. Now this API gateway is going to invoke AWS Lambda. Again, this is a serverless. Invoking means they are going to send the request or get the response. That's what invoking means. So इसने invoke किया AWS Lambda को. Now this API, let's suppose REST API, this wants to make few changes to the DynamoDB. They either want to read a data from DynamoDB, or they want to uh, write the data to the DynamoDB. So it is going to invoke, and the query is going to be reached to the DynamoDB. Okay, so this is how based upon this previous scenario, if your user should be able to directly interact, they need to verify the passwords, to do lists, read कैसे करना है. For this, these are the 3 or 4 services that are required for the required tasks. In the same way, based upon the different business requirements, we can have the different services that are going to be working on this one. Let's see that mobile app giving users access to the S3 bucket. Now, here you will see it is a user should be able to directly interact their own folder in S3. How we can have this thing working? For this, beta we'll have the S3 bucket. Now, should I provide this mobile user the right to access this S3 bucket? Better read this statement once again. You should be able to directly interact with their own folder in S3 bucket. So should I provide them access to this complete bucket? Beta, yes or no? Should I provide them access to complete bucket? The answer is nobody is participating. The answer is no. If this user has some of the data which is stored in this S3 bucket, let's suppose I have an image of the coffee or the image of the car which is stored in S3 buckets, and this user wants to have an access to that particular image, I should not provide the access to the complete S3 bucket. So what is required to be done? So first of all, I am going to authenticate the user using the Amazon Cognito. Now once the user is authenticated that yes, this is going to be the right user, then I can use this Amazon STS, which is going to generate the temporary credentials. So we are not providing the complete access to Amazon S3 bucket for this users. We are going to generate the using STS service. Temporary user IDs and credentials is going to be generated. That credentials is going to be provided from this mobile user to this S3 bucket, because these are temporary. So this will not be able to access the entire service. So basically this STS, AWS STS acts as a store, acts as a permissions granting or the revoking. So it can either grant the permission or it can either revoke the permission, and you can store or retrieve the files. So this is how the mobile application you can get the access to S3 buckets, but not complete bucket for any specific data. For that, first of all, I need to authenticate. Once it is authenticated, I'll be generating the temporary credentials so that it can visit to the S3 buckets and get the contents which are required. Okay. The third step is high read throughput static data. Let's move to the third point. So it is written. So the user can write or read, but mostly read them. So high throughput read. That means my user should be able to read maximum time. 90% of the cases my user should be able to read, and it should have the high throughput. So how we can have this thing working? So let's try to understand. Okay. Now to have this beta, first of all, the view of the structure will remain same. So mobile client, authenticate user, get the temporary ID password, then move to the S3 bucket, get the contents. Using the REST APIs, you can go to the API gateways, you can invoke the AWS Lambda function, and this Lambda function between DynamoDB, you will observe a DAX caching layer is there. Okay. Now this is a DAX caching layer is there, which is going to provide you with the high throughput. But a high throughput means that the time required for the fetching up of the or whatever result, whatever queries you are invoking using the query read or write, so it is not going to the DynamoDB directly. So temporarily, it is going to be a caching layer is going to be in between them, which we call as a DAX caching layer. Okay, so this is going to temporarily hold the data, and when the next time the query is going to reach on the DAX caching layer, it is going to get a response from this one, and it is going to send to the AWS Lambda, and so the mobile user is going to get the response. So to get a high read throughput static data, I'm talking for the static data, so we'll use the DAX caching layer. This is the important point. We can still increase, but इससे भी ज़्यादा हम लोग speed increase कर सकते हैं. कैसे? We can use the elastic cache. So elastic cache, we have already studied the concept using the Amazon API gateways. So with this, we can use the elastic cache, which is further going to increase our the speed for the throughput. So you can see here in the previous slide and in this slide, so caching at the API gateway level. So not at the database level, you're not going to have the caching, which is DAX caching, but you're going to have at the gateway level caching of the responses. So Amazon API gateway can also have the elastic cache that can come in hand. So in order to increase the read throughput. Now combined this elastic cache and the DAX caching layer, better the speed of retrieval will be increased quite a lot. Okay. Coming on to the next one. So serverless REST APIs, we have the HTTPS, API gateway, Lambda functions, DynamoDB, and using Cognito, we can generate the temporary credentials. Okay, with the STS to assess the S3 bucket and restricted policy. We can have the bucket policy as well. Okay, so we can use the bucket policy. But a bucket के यहाँ पे भी हम policy use कर सकते हैं that no direct mobile user can access it. Only the gateways can access this. We can have this policy as a bucket policy. So that can also be done. API users can directly access the AWS resources this way. Pattern can be applied to the DynamoDB and Lambda. Caching the reads on the DynamoDB using the DAX. Caching the REST requests use the API gateway. So these are going to be two different caching. Okay, so don't get confused between these 2 points. Caching the reads on DynamoDB using the DAX caching layer, and you can cache the REST request as the API gateway level. Both of them are going to be different. Security can be implied using the Cognito tool provided by the AWS and using the temporary passwords generated by STS. Then serverless hosted website. Let's suppose you have the myblog.com. If you want to host a website that is myblog.com, so what are all the components or what are all the services that needs to work together in order to execute this? I've got a message. No. Okay. Now, serverless hosted website. Let's suppose I have a website with the name myblog.com, and how this is going to be executed on AWS without any server. So this website should scale globally. And what are the functionality that I want in this website? That website should be capable of scaling globally. So whatever I'm going to upload, so it should be able to scale globally, irrespective of the region where I have deployed it. So blogs are rarely written, so but often read. So I need to have the cached DAX caching layers needs to be there, and there needs to be the API level elastic cache needs to be there. So blogs are rarely written because one person is going to read and thousands and lakhs of people are going to read. So it needs to have a high read throughput needs to be there. Some of the website is purely static files. The rest is dynamic REST API. Okay, so they can use the dynamic REST APIs for the better working. Caching must be implementing wherever it is possible, so that we have seen. Any new user that subscribe should receive the welcome email. So this is also my requirement that whenever any new user is going to subscribe to myblog.com, they should receive a welcome email. And any photo uploaded to the blog should have a thumbnail generated automatically. So this is also one of the conditions. So if you are going to make a website something like this and you want, these are your requirements. So in that case, what are the components or what are the services that are going to be come in handy so that we can execute this website completely. Okay. Now for that, serving static content globally, beta, we need to have the Amazon CloudFront global distribution. So suppose this is the client sitting in the Mumbai, and this the bucket is in New York. Okay, so you want to assess from sitting from Mumbai, you want to assess anything from the New York. So you need to have a CloudFront global distribution. Okay, so global distribution means it is going to be attached with lot of edge locations. If you remember, we have discussed this CloudFront global distribution. It is connected with lot of edge locations. So CloudFront to CloudFront global distribution network internally AWS is going to have, and moreover this is going to replicate the data to the nearest possible location. Okay, so interaction with the edge locations can be done if the storage and the user, if they're not present within the same region. So we need to use the CloudFront. Okay, so the first answer to this is this website should be scaled globally. For that I will be using the CloudFront global distribution. एक चीज तो एक service, one of the services clear that I'll be using the global CloudFront. Okay, the next one is going to be CloudFront. Now this client again should not be directly able to access this website, so my CloudFront should be able to access this bucket in order to invoke the security. Okay, so any of the user from the globe should not be able to access this bucket. So rather than that, I am providing the permissions to this CloudFront. Internally this CloudFront service can attach to the AWS S3 and they can get the files from here. So OAI, that means origin access identity. So this CloudFront will be authorized to use the S3 bucket, and moreover, see, it is written as a bucket policy can also be employed so that only the CloudFront can access this. So this is invoking the security. Now coming on to the next one, adding a public serverless REST API. Now since it is a read-only blog, because it is going to be the static website, so I can have the read-only one. So how we can do this? So REST APIs are going to be used for the Amazon API gateway. It is going to invoke the Lambda function. Queries read and write going to be done in the DEX caching layer. If not present the DEX caching layer, it is going to be in the DynamoDB, and to make it present globally, which the data is might present in the AWS 3 bucket, while be using this CloudFront global distribution. So this is also done. Next one is leveraging DynamoDB global tables. Okay, so global tables, how we can have this, that we'll see in a moment when I'm going to open the DynamoDB. But after this we'll see the practicals of the DynamoDB, and I'll see you how we can create the table. So rest is same. And coming on to the next one, user welcome email. So let's try to see this. REST APIs will go to Amazon Gateway, invoke the Lambda function, get the DEX caching layer. Once the data is being stored in the DynamoDB, so you can have the stream changes. So whenever the user is going to upload any of the image, that image needs to be set as the thumbnail. So for the streaming changes, I will be invoking the DynamoDB again, invoking one of the code written in the Python or the Node.js, or any of the programming language. I'll be streaming the changing using the Lambda, and the IAM roles needs to be done using the SDK. Now what is this SDK? To send an email, beta SDK is the service that is going to be provided by the Amazon, which is called as the Amazon Simple Email Service. So using Amazon Simple Email Service, SES, this can send a welcome email to the user. So you can see, just to send a welcome email, lot of services are required to be used here. Okay, now for the thumbnail generation, better from this, see the difference from this Lambda function, you are reaching to the simple email service, and from this Lambda you will also be reaching parallelly, better this will also be triggering one of the event in the Amazon S3 bucket using the CloudFront global distribution to send it as a thumbnail. Okay, so these are all the services, and of course S3 this is kind of optional. SQS and SNS for the sending of the text message you can use from this bucket already. Okay, so read this beta, AWS hosted website summary. Read it once. Okay, so but before we start with the DynamoDB, before we can create a table in the DynamoDB database, so let's try to read the uh, DynamoDB. Okay, so in Amazon DynamoDB, this is going to be the fully managed, highly available with the replication across multiple availability zones. So that is the virtual database that we can have. So no SQL database, so it works on the no SQL database and not a relational database. Okay, so not a relational database means you cannot have the joins operation perform the inner join, the outer join. So that thing cannot be performed, and because that can be performed in the relational database. So scales to the massive workloads distributed database. So that means it can automatically scale up and scale down based upon the business requirements. Millions of requests per second can be performed, trillions for a row, hundreds of terabytes of the storage. You can imagine how frequently and how bigger size this database is going to be. DynamoDB, faster and the consistent performances, low latency on the retrieval, integrated with the IAM for security authorization administration, enable the event-driven programming, so it can work very fine smoothly with lot of programming languages as well. Enable the event-driven programming, okay, slow cost auto scaling. So all these are the services that are being provided. Now DB is made up of DynamoDB is made up of tables. So that means whenever I'm saying we'll be practicing DynamoDB, but we cannot create a database. DynamoDB we cannot create a database because it is internally the database is created. But instead, what we can do is we can create a tables into it. So when we are going to have a hands-on practice for the DynamoDB, we'll try to create a tables instead of DynamoDB database because that is not allowed. Each table has a primary key, must be decided at the creation, and table can have the infinite number of items, that is rows. Each item has an attributes, attributes can be name, age, salaries, education qualifications. So all these are going to be attributes. Maximum side up to 400 KB for any row that we are going to have. Scalar types, document types, set types. So these are types of data that we can store into the database. Okay, then this is a very easy example given. What can be a primary key? So any partition key, any sort key, you can combine them and create a primary key. Any of the another columns that are left that are not a part of the primary key can be treated as the attributes for that particular column. Okay, and the last one is going to be the provision mode or on demand mode. Okay, so the next one is provision modes and on-demand modes in the read-write capacity. So you can control how you manage the table's capacity. So provisions mode, this is more expensive. This is three times, but generally this is three times more expensive. This is generally three times more expensive than on-demand mode. Provision, do you specify the number of read write per second? You need to have a plan capacity beforehand. So you need to be very calculative how your business is going to operate. But if you don't have the idea that how the business is going to operate, you can go for the on demand that can automatically scale up and scale down. But in the provision mode, so you need to have a clarity beforehand. So you can pay for the provision read write capacities RCU and the write capacities WCU. Possible to add auto scaling mode to read and write. Coming on to on demand, this is comparatively cheaper as compared to provision modes. Read writes are automatically scale up and scroll down. And sorry, this is on demand. This is three times on demand is three times more expensive. Okay, read write automatically scale up down, no capacity for planning needed. So that means if there is an abrupt increase or decrease in the services provided by your company or the website, so you can go for the on demand, pay for what you use, great for unpredictable workload. So this is generally for the unpredictable workload. So let's move on and see how we can create a table using the DynamoDB. Okay, uh, let's go to delete this. Done. But very soon I'll show you the billing dashboard towards the end of the training, because I think I have started lot of services and I might have not uh, closed them. So will you understand? Current month total forecast $1, $1. Active services, you can see total number of active services 15. So I need to shut all of them. Total number of active AWS regions is 18. Account is this much. Current MTD balance is point this it. So you can see, okay, account cost, bills overdue, credits, purchase cost. We'll see it in the upcoming class how we can save on this cost. We were supposed to use the Dynamo, Dynamo DB. Very easy. So create a table you will find. So you cannot create a database. So it is written Amazon DynamoDB, a fast and a flexible NoSQL database service for any scale. So create a table. Okay. So you can create a table using this. Write down the any name of the table. So let's write demo table. Okay. Then you need to choose the partition keys and sort of optional key, and you can, it can be binary number, string, or anything. So you can choose this. And sort key, that's an optional one, you can keep this. And the length should be from 1 to 255 characters, and it is going to be the case sensitive. So let's suppose I'm going to have here is user ID, user ID. And why I'm writing this user ID, because beta keep in mind partition key मैंने अगर user ID लिख दिया, now one I'll be creating the table. In that table I need to keep user ID as one of the attribute. Okay, keep this thing in mind. ऐसा नहीं है you're giving different attribute here. While creating the table you're giving a different attribute, it needs to be same. So I have given the user ID here. Okay, so this sort key is optional, so I'm going to leave it as it is. Now you can either use the default setting or you can customize the setting. So in default, faster way to create your table, can modify these settings now or after table created, or you can have the customize setting. Okay, so let's, if we click on the customize setting, you can see the different options here. We can have the DynamoDB standard or DynamoDB IA as a table. Infrequent access table when there. So infrequent access table we have studied during the start of the training is 90% cheaper, because it's very rare we are going to access the infrequent access table. Okay, so you can see the then read write capacity. Either you can choose the on demand or you can use the provision. So we have seen that both of them. So if you are going to see the provision, so under this uh, or if you're going to use the on demand, simplify billing and paying for the actual reads and write or your application. Okay, so let's move and see. Or even if you'll click on the, let's see the provision one, read capacity, auto scaling, you want to turn auto scaling on or off. If I'll put the auto scaling off, the provision capacity units is up to 5 unit capacity is going to be reserved. But if I'll click on turn on the auto scaling, so minimum capacity, maximum capacity is given, and the target utilization. जैसे बेटा 70% of the target will be achieved. Let's suppose 70% of 10 will be 7. So the moment the capacity is going to reach to the 7, auto scaling group will be increasing the capacity. Okay, so you can turn on and turn off the auto scaling. And by the way, this auto scaling is applicable to both this one, read and write. You can have the write auto scaling as well. Okay, now let's move and see the next one. Total read capacity unit, total write, region US East 1. Estimated cost is US dollar 2.91 per month. So of course, this is not a paid one. To use the DynamoDB, this is the paid service. So let me reduce it. I'm going to turn it off. Turn it off. I don't want to have this much units. Let's reduce it to one. Let's also reduce it to one read unit and one write unit. Estimated cost, you will see I have reduced it to 0.59 per month. Okay. So it all depends upon read and the write units that you can have. Now we'll have the secondary indexes if you want to create it, but I'm not going to create it. Okay. Let's move on to the next one. And by the way, if you do not know, let us suppose if you do not know, I have choose it one because I want to have the minimum capacity one read unit and one write. Now someone can ask, sir, how will we come to know how many read capacity units are required on how many write? But that will depend upon business to business. But here you will scroll and अगर आप यहाँ पे जाएंगे तो capacity calculator. So you can calculate how much capacity will be there for you. So read consistently, write consistency, average item size, item read per second, item write per second. So based upon that, you can decide how much read and the write capacities are required for your particular business. And then which encryption mechanisms is going to be when the data is going to be stored in the DynamoDB database. So how encryption should be performed? So owned by the Amazon DynamoDB, which is going to be AWS KMS, which is we have used throughout up to now. Or you can have the any other the encryption mechanism. If you want to apply it, you can use that as well. So but these settings are good for us just for the practice, and let's try to create our table. Okay, so table is being created, and you will see the partition case user ID status is being created. Read capacity provisioned 1, write is 1, size 0 bytes, done. So this is being created. Now let's click on demo table and see further few of the details. And here you will see okay. So here you'll see the lot of other details are going to be present here. I'll click on the demo table. And partition, lot of table status active, no active. Okay. Okay, let's first of all put up some items into this one. So I'm going to click on explore table items, and we are going to insert few items here. So no item is present here, you can see here. So I can go on create item, and under create item you will see the user IDs automatically, which is the partition key. Okay. And you can have the my name as Sahil underscore, let's suppose 123. That is going to be the user ID. And let's add new attributes to this. This is one of the attributes, user ID. I'm going to, for this table, I'm going to add these attributes. Let's have the next one string, and I'm going to create it as the name. Create few attributes, and let's have another new attributes. I'll write favorite color. Suppose like white. Let's have one more attribute. So the number of attribute, whatever attribute you want, you can have it. Let's take the another one. pick any random value. So I'm going to create few of them. Let's create an item. Okay, so this is complete, and under this you will see this is the partition. One user ID is the main, and favorite color, favorite number, name, everything is present here. Okay, so we have created already. Let's try to create another one. एक और create करके देख लेते हैं. Let's create Bob underscore 123 to 4. Let it be as it is. Add a new one. Let's create a number. Phone number ph underscore. I'm going to add the phone number. Let's suppose this is the one, and let's suppose I'm going to add the string favorite uh, color. Let's suppose black, and let's suppose attributes. Let it be number again, and let it be fee. Let's take value is 5,000. Okay. So why I have taken why I have taken the attributes in such a way that because I want to explain you that user ID, this is the mandatory one. So Bob underscore 124. Then favorite color is matching with the previous attribute. पिछले में भी favorite color था, इसमें भी है. But you can see the phone number and the fee we have not taken in the previous attributes. But still, that's the beauty of this DynamoDB. So we can still create these items. So whatever items we want to insert, whatever the values we want to insert, we can insert it. Now you will observe that a few of the items are going to have the similar details like favorite color. So this is black for Bob and white for Sahil. And favorite number, I have only favorite number I have entered it for Sahil, which is 34. And I have not used this particular attribute for the Bob. And coming on to the fee attribute is only used for the Bob. Fee attribute is not used for the Sahil. And similarly, name, contact number. So this is how you can use the DynamoDB database. Done. What else we can see here? Let's move to the DynamoDB and see. Okay, not this place. Let's go to the tables, demo table, and these are the few of the another important details. If you want to have the total capacity metrics, read कितने बार बेटा हुआ, read throughput, read throttle, write usage, average, and you can see this matrices, then indexes, monitors. Okay, CloudWatch alarms is already enabled into this, no alarm set. So if I want manage CloudWatch alarm, I can set an alarm here. Okay, so these are few of the backups and export. You want to have the backup or you want to export. Okay, export to S3 bucket. So if you have the database and you want to export it to S3 bucket, you can use this as well. So a lot of other details are global tables are mentioned here. You can replicate the table from one region to the another region. So all these services are present here. Okay, so that's it for a DynamoDB table as well. So let me delete this. This is gone. List of tables. Let's remove this one. Okay, so better let me take the attendance before you can leave the session.